guys. So be sure to subscribe to my channel. So in this video, all we wanted to prove is the Cauchy Riemann condition, and for the analytic function. So for the analytic function f. Okay, so what we want to prove is that if limit delta f delta z basically exist, then if only if the Cauchy Riemann holds. Okay, so let's say f is u plus iv, where uv is complex, uv is a real function. Then Cauchy Riemann makes that ux equals to vy and uy equals to minus vx. Okay, so ux is just a partial u partial x, and and the vy is just partial v partial y. Okay, so we want to prove that if the limit, okay, let's say what is the limit, right? So limit just fz plus delta z minus f of z and the delta z, and you just let the delta z to be 0. And I want to prove that if the limit exists, if only if the CR holds. Okay, so the proof is not difficult. Okay, so let's start for the first one. So everybody remember the condition. Okay, so the proof is, the first one is that the limit exists. Okay, CR holds. Okay, so the proof, let's say we can write delta z as a delta x plus delta y. Okay, everyone knows about this. And the delta f is delta u plus I delta v. Okay, so delta u plus I delta v, delta x plus I delta y. Limit delta x goes to 0, delta y goes to 0 exist. So this is the condition. Okay, so let's say we take two possibilities. The first possibility is that delta x goes to 0, but delta y is 0. Okay, so you get the delta u plus I delta v divided by delta x. So it's ux plus I v y. Right, as your delta x goes to 0. And the second condition is the second way to approach it is delta y goes to 0, delta x is 0. So where delta x is 0, you get 1 over I and the uy plus I vy. So this should be the same. Okay, so what this shows is that ux equals to vy, right? Because this I cancel, and uy equals to minus vx. Okay, so this is the CR. Okay, so the proof is complete. Okay, and the second thing we are going to prove it is that if CR holds, then the limit exists. So it's like the converse result. Okay, so second, prove if CR holds, limit exists. So proof. Okay. Let's say that so it's very stupid that we know f is u plus iv, right? So another way to write f is just use a total derivative. So it's ux plus ivx delta x. So this is the x for derivative and the uy, right? Okay, so everybody knows about this. And delta f divided by delta z is the same thing, right? So we just put the numerator and the delta x plus I delta y. And somehow like we use a trick, right? So we divide it by delta x and we get this. Okay, so this term survive plus this uy plus ivy. Okay. So now we can use our CR, right? Our very careful, beautiful CR. So what is this CR tell us? CR tells us that maybe I choose a color, much easier. So ux, not very easy. So let me just change the background. Sorry, I'm stupid. Okay, so let's say that CR, right? So ux equals to vy, uy equals to minus vx, right? So this is our stupid CR. Okay, so what Cauchy Riemann tells us is what? It's this uy, right? This uy is just minus vx, vy is just ux. Okay, so I miss iy. Okay, so this is what do we get? We get ux plus I Vx plus minus Vx plus I Ux. Right, we just change this. Right, so Uy is just minus Vx and the delta y delta x. 1 plus I delta y delta x. Okay. So what's going on? What's going on? What's going on? Okay. Okay. So what's going on? So this is delta z. So we we want to prove is this limit exists, right? As delta y delta x exists. Okay. So if you see carefully, maybe we just write it carefully. You see, uh, what is the yeah. So what is the Vx? Well, what is the delta y delta x? So it's uy partial vy, right? So we change it to minus vx plus ux. Okay. So if you see carefully, at least delta f, right, divided by delta z, it turns out to be partial u partial x plus I partial v partial x. Okay. So it's basically ux plus I vx. Hopefully you guys can see. The reason is that you get this uy plus ivy. This is minus vx plus ux, right? So we want to prove that the delta z, this limit is respect to whatever delta x delta y. Right. So it's obvious that if you see the you see. Okay, so maybe let me just expand it. Okay, so we get this. Okay, so the ux term, right? So let's say ux term is delta x. Okay, so maybe now you guys see a trick, right? Plus vx and I delta x minus delta y, right? So we can actually change this to be plus I and divide and pull I out. Okay, so these two terms cancel, right? So this is a trick. Okay, so finally you get ux plus I vx. Okay, so Cauchy Riemann, what Cauchy Riemann tell you is that if CR holds, then delta f delta z is fixed as ux plus I vx. So delta f delta z exists, right? Since if CR holds, then we are already guaranteed that ux and vx exist, and now delta f does not depend on the path as what we choose. Okay, so the proof is done, right? We prove the limit exists. Okay, so that's the Cauchy Riemann condition holds, and okay, and the next that I will let me give a very short proof about orthogonality. Okay, so basically, if you have a line U is C and you have a line V is another maybe C1, C2, and I want to prove that there will be two curves will be orthogonal. Okay, so that's what I want to prove is that ux vx uy vy will be -1, and the reason is very stupid, right? Because ux is vy and vy is minus vx. Okay, so this is the same, right? But if you just return out, if you just spell it out, then you will be that these two are orthogonality to each other. Okay, so that's it. So I will see you guys in the next videos. Be sure to subscribe to my channel. Thanks.